so next section, it's kind of a, doesn't have anything to do with the last couple ones, but postulates and diagrams. So everything I'm about to write is in a chart on page 84. And so I will never ask you what's postulate 2.1. I just would expect you to know the information, not the actual number. The example that I use is I referee water polo. I have for a really long time, and one of the rules says that you can't touch the ball with two hands. I have no idea what the rule number is. I just know you're not allowed to touch the ball with two hands. And if so, then it's a turnover and the other team gets the ball. The information is the important part, not 2.1. Okay? So I will always label them, or most of the time I will label them, just for, like, if you need to look it up kind of thing. But I will never ask you to remember those. So 2-point postulate. Through any 2 points, there exists exactly one line. Postulates are rules that we use in geometry. They tend to be more straightforward, more direct, easier to understand typically than theorems, which are the other things that we'll talk about down the road. Through any 2 points, there exists one line. So here I have point A and B. How many lines can you draw through it? Well, just one. That's all it's saying. And so postulate 2.2 goes with the same idea. A line contains at least 2 points. So it's kind of going backwards. If you have a line, you have 2 points. If you have 2 points, you have a line. Oh, I forgot to put the title. Line, point, postulate. Okay, so on the first one, you start with 2 points, therefore you have a line. The second one, you have a line, therefore you have 2 points. So it's kind of like a conditional and a converse. You can go in both directions. Or a biconditional statement, where if you change the directions and it's still true. Okay. Postulate 2.3, line intersection. If two lines intersect, then their intersection is exactly 1 point. Use these emphatic words periodically. That should make sense. If two lines cross, they cross at a point. Exactly one. There's no way to have more than one. All right. So 2.4 4 and 2.5 go together, so that's why I did a separate thing. This one's the 3-point postulate. Through any 3 non-collinear points. Sorry about that, I bumped. 3 non-collinear points, there exists exactly one plane. So if you think about, it's kind of hard to do on a two-dimensional thing on the iPad, but if you think about, if you put 3 points on your wall, there's no way to draw a plane that includes all 3 of those points other than just the wall. There's no way to connect them any other way. So you'd have plane A or whatever. Okay, so it's kind of a definition of a plane, 3 non-collinear points. So whatever, you can label those points however you like. And so then 2.5 is kind of like the opposite. Plane point. So a plane contains at least 3 non-collinear points. So it's like the 2.1 and 2.2 where you can go both directions. If you have 3 non-collinear points, then you have a plane. If you have a plane, then you have 3 non-collinear points. Okay? Alright, 2 more. So postulate 2.6 is the plane line postulate. I haven't been writing the word postulate at the end of them, and that's okay if you do or you don't, but if 2 points lie in a plane, then the line containing them lies in the plane. So if I have some plane, I have points A and B that are in the plane, well then the line that connects them or contains them is also in the plane. Hopefully that's pretty straightforward. And last one, plane intersection. If 2 planes intersect, then their intersection is a line. So this is a lot harder to draw. think about two planes intersecting, that would kind of be like the floor and the ceiling, or excuse me, the floor and a wall, or the ceiling and a wall. I don't know if that looks the way that I wanted it to, but if two planes intersect, so if you look at your wall and the floor all the way along the bottom where they meet would be a line. So some line like that. Okay, so a lot of them, like the name kind of helps. Plane intersections. So, okay, that's telling me that's what I have. I have two planes. Okay, they intersect at a line. Like 2.6, I have a plane. Therefore, like if there's 2 points, there's a line. So it's kind of, we had 3-point postulate, 2.4. Well, if I start with 3 points, then what do I have? I have a plane. 2.5 plane point postulate. If I start with a plane, then what do I have? I have 3 non-collinear points. Okay, so let's look at a couple of problems. There's really no work to do today or to show today. So let's look at a couple things. So your first few problems, it might say if that, then it's pretty straight. Not really. So it would say, like, what postulate is being diagrammed? So the way that, like, I kind of process this is, like, I ask, like, what do I have? Well, in this picture, what I have is 2 lines intersecting. So then if I go back to the postulates, 2.3 line intersection postulate starts with if 2 lines intersect. So if 2 lines intersect, then they intersect at 1 point. What do I have on the second part? I have a point. So the answer to this one would be the line intersection postulate. So there really is just looking at a couple of examples and figuring out, like, which, like, one, fits. Okay? And that's pretty much going to be, like, the whole assignment is just look at this and which postulate is being represented. So your second group, I'm trying to use some examples from the book because I know they'll work out nice, but I have to draw 2 planes again. Try to use the erase tool here. it's gonna finish diagramming everything. So the directions will say, use the diagram to write examples, and then it's going to tell you of the plane point postulate. So it's going to tell you which one to use. And so it just wants you to be specific. So the plane point postulate says a plane contains at least 3 non-collinear points. So then it wants you to just be specific in that. So where do I have 3 non-collinear points? Well, A, B, and C. And they're in plane P, if you look down here. So what I would write is, so if I'm writing plane point postulate, I would say plane P contains the 3 non-collinear points A, B, and C. So the plane point postulate again says a plane contains at least 3 non-collinear points. It wants you to say what plane and what 3 non-collinear points. Okay. So we could also have plane, there could be a bunch of them in this one, but if it said write an example of plane line postulate, well, the plane line postulate says if 2 points lie in a plane, then the line containing them lies in the plane. So what 2 points are in a plane? So you could say, well, I know that A and B are in plane P, so you kind of fill in the information. If 2 points lie in a plane, that's the general form, we would say points A and B lie in plane P. So line N, so we have this little, remember lowercase letters at the end of a line mean we can just say line N. If you said line AB, that's fine too. But line N containing A and B is also in plane P. So you'll have a few problems where they give you a something to look at, like a figure to look at, and it's going to say write, and so it just means be specific. So again, that last example, plane line says if 2 points lie in a plane. Well, what 2 points? Points A and B lie in a plane. Then the line containing them. Then the line, so line N containing A and B is also in the plane. Just fill in the information instead of just being like a general form. Okay? And then honestly, there's going to be some that it just wants you to draw a diagram of what's being described. Do the best you can. I just want to see what you come up with. So I'm not worried about right or wrong per se on the just sketching stuff. So just sketch the best diagram that you can and don't overly stress over it. But should be just it's kind of a different section, but really look over again on page 84 is a chart with all those postulates if you want to use that like as well. But all right, hope that wasn't too terrible. Please ask questions if you have any along the way, and I'd be happy to help you. Remember, you have a quiz tomorrow over sections 1, 2, and 3. So conditional statements, converse, inverse, contrapositive, biconditional, all those statements from section 1, inductive and deductive reasoning from the last section. Remember, primarily inductive for what we do, and then the postulates. All right, have a great rest of your day, guys. We'll see you tomorrow.